On October 25th, we're coming back to Melbourne for our first physical MLOps event. Whether you are just starting in the MLOps journey, improving in that space, or whether you have thousands of models in production, this event is for you. The type of things we're going to cover is MLOps for scale, and that scale can be number of models or the number of people in the team, or the number of prediction and inferences that need to be made in an hour or a minute or a second. So how to create effective MLOps for all those scenarios. We're going to cover MLOps processes and team structures. How do we organize ourselves and the talent that we have in our organizations for better results in MLOps? We're going to be looking at creating efficient and effective MLOps pipelines in an end-to-end. What does the data look like, the feature stores, all the way to the model deployment, serving, monitoring, alerting, etc. We're also going to cover getting a C-level buy-in and support for the investment in this area. We're going to be covering what governance and good management looks like in this space. So wherever you are in your journey, the MLOps event in Melbourne on October 25th is going to help you increase the maturity of MLOps in your organization. I hope you can join us. See you then.
I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project-focused data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au. Welcome everyone to our first panel. So I just did the intros of our panelists. So we're here with Kendra, Ram, Gus, and Farhan. And we're going to be talking about scaling MLOps in the enterprise. Some of the things that we want to be discussing is team structures, different approaches there, getting business acceptance, productionizing models, tech approaches, going from prototype to production, and with that, maybe I'll start by asking Kendra on views on the team structure. How are you guys organized in Xero to make the in from an MLOps perspective, and how do you guys think about it? And then I'll ask for different perspectives on the same. But Kendra, if you can kick us off.
Thanks for having me. It's really cool to be here, and hello to everyone watching out there across the world. So at Xero, how do we structure our ML ops team? Maybe I'll answer a slightly different question, is how do we approach ML product build? So as with the rest of Xero, we have a plan of you build it, you own it. What that means for us is we build in sort of integrated product teams. So we don't have data scientists on board. We call them applied scientists. You know, everyone's going to have their little quirks about how you change people's names. So we work with a team of product managers, applications engineers, and applied scientists all together in a delivery pod, and they will take a product from ideation around what is a service that makes sense for Xero and our users through to and into production and usage. We're relatively early in our journey, so we're not yet at the point of sort of a product that is very, very stable and has been running for many, many years. Most of our ML products have only been in market like a year, a couple of years. And so they're still also in the very active development phase, where we would be expecting to push new features and new pieces of the product into market relatively regularly. So for us, that cadence, that group composition works really, really well. We also try to focus on building multi-headed services so that the ML product team, the team that is building that particular ML inside service, would often be working with two or more customer touching teams who perhaps you might think of as own the Chrome. So that, I guess, brings another dimension to the way we think about and put our teams together.
Yeah, really nice. And one of the things that Kendra said to me before, when we were chatting before this, is she highlighted that there's no one size fits all approach. That there's different. It's essentially horses for courses, and that part of what we want to do in this panel is bring you some of the different approaches that we have in the way that we structure teams. So Ram, I wanted to ask you from your perspective, how do you structure your teams from to create ML products and then the MLOps side?
Yeah, thanks, Felipe, first of all, for having me. And hello to everyone across the globe who joined this. From a Woolworths and Woolies X perspective, it's slightly different, like in terms of how we have gone about, in this journey. We've got data scientists, and then we've got machine learning engineers. The reason we kind of went through that is because data scientists predominantly build the models, train the models, build the models. They work with stakeholders and understanding the problems that they're trying to solve. And then we've got the machine learning engineers who help in scaling and productionizing the models. Obviously, there's going to be crossover of skills between the data scientists and machine learning engineers in our team. And we focus on that as well. But we also realized that in order to scale, we needed to develop this practice and bring in expertise, wherein we've got machine learning engineers who help the data scientists from, in terms of productionizing the model itself. So, and we work in an agile setup. So every product that we build will have a squad, and within the squad, you've got product managers, then you've got data scientists, machine learning engineers, and also other skills that you might be required to deliver that particular product. So it's coming together of all the different skills that we need to bring that machine learning product to life. And that's how we have scaled in the last few months, and it's been incredibly successful for us. And we've been able to build some of the ML products, and they are in production, and we've seen some great success with our customers based on the AI products that we have developed.
Fantastic. That's excellent. Gus, from your perspective, tell us a little bit about how you guys are structured, and then tell us a little bit about the different skills that you see that the different teams need in order to make MLOps a success.
Sure. Thanks, Philip, for having me here, and hi everyone. And yeah, well, the AI at Castle starting about 5 years ago. Yeah, at that time actually we are giving AI a go. So the journey from that point on actually define our strategy currently. Yeah. So when we're starting this AI journey, we have no AI talent data scientists whatsoever. Yeah. So it's just a few of software engineer, the one who's really passionate. We're trying AI, we're learning data science skill. Yeah. And as we develop the AI technology the next few years, we're starting to realize that, building the AI tech is not just building the model. Like you also need to actually operationalize it and productionize it to build the continuous training and things like that, right? And serving for inference. And we have no issue with that because we all come from the software engineering background. So we do not realize that this MLOps is actually an issue. Yeah. Until just recently, this is becoming like a new kids on the block. Everybody talking about it. It's a blocker from many organizations because they're too focused in hiring just building data scientist team, but there is no engineering component. So that's what happened in 5 years ago. And then starting 2 years ago, we starting to grow, right? So we start having like a data science team within the Castles. And our team, our AI team, prior to that, we are the one who do end-to-end, building the model, productionizing it, everything we do from end-to-end. And starting 2 years ago, we start becoming a helper to this team to enable productionizing the model, right? And then just like recently, we're starting to realize that the data science team and our team is not a big team. In total, maybe less than 10 people there. And the demand for AI is growing more and more throughout the entire organization. Yeah, many departments wanting to build AI model, they all come to us, and we become the bottleneck. And we also starting to realize that this is not like 5 years ago when building AI technology. Yeah, most of them, any good software engineer with a good logical skills, right? They can learn this easily, especially with the help of lots of high-level services. Yeah. So I wouldn't say like all AI model you can build without the data scientist skills. No, but currently 50% of AI model you can really build just using these AI services without very little bit of like a help and guidance. Yeah, in a data science area. So with that, at Castles, with attempting this new strategy, we try to actually enable AI on all software development team. Yeah. So at Castles we have about 10 software development teams, yeah, and each one of them have their own like a silo with a product designer, right, deploying their own product. So we want to enable each one of them, yeah. So what we do now, we actually turning whatever the MLOps platform that we have in our team, yeah, to actually install it in every single one of these teams, and then also giving them guidance, enabling them to actually deploy end-to-end AI, and also to pair up with the data science team, yeah, to actually help productionizing their model. Yeah. So this is the strategy we are taking on. Yeah, it's actually win-win for everyone, right? For the business, it's good because you do not need to spend a lot of money hiring unicorns, right? Data scientists, right? And for the software developer, also good as well because giving them ability to learn and opportunity to learn. Yeah, and also data scientists who wants to build a very simple AI model, right? Let other people do it. I will just do all the complicated one, right? So that's our take on this. Yeah,
that's really good. And the data coming in to all those different teams, is that largely centralized from a data preparation perspective, or do people look after their own needs largely? How is that split?
That's a good question, Philip. So there is a data platform and engineering team within Castles who actually coordinate all the data into one central repository. Yeah, so we call it data lake, and so everybody tapping into this. Yeah, but like I said, we're just starting to try to democratize this AI enablement to all team. So at the moment, 90% of AI tech development is just built by our team and this data science team pairing up with us. Yeah? So we will see in the next 6 months or 1 year that other teams start consuming this data and building their own model pipeline. Yeah. So
great, excellent. And Farhan, from your perspective, can you tell us about in your experience where you've seen some of the teams and skill sets, and then tell us a little bit about how what are the stages that people should move through when they go from a prototype model moving into production?
Yeah, sure. So I think from a perspective of moving from prototype to production, it also tells you like what kind of skills you should start to incorporate, right? Like you can start simply with a single Python script that can generate a CSV and just put it on a data store, and that can be somehow consumed. I mean, you can go with something super raw to having something that's like a real-time inference engine, for example, at a point of sale for a credit card, to check for fraud. So you have that whole entire spectrum. And this we should split this up into like what are actually the necessary kind of areas that are required, right? So you've got data and data pipelines that feed both your training and your inference. You've got the actual training process, and then you have inference. And when I say inference, that's the point at which you're actually using your model, right? And it's typically these are the three kind of areas that you need to invest in to scale. So you need to scale the pipelines and make them reliable. You need to scale the training and make it reliable, and then you need to scale and make sure that the inference is actually at scale and working at the speed that you need. So now that you have these three components, now if we think about what the data scientist does in their prototype stage, they'll maybe just extract some data, do some training, and then do their inference on their side. To take this to production, you've got a few components, like you've got data skills or data engineering skills definitely required to make sure that the data that's coming in doesn't require like a crazy amount of processing, or the data architecture is such that it's fairly straightforward to build that pipeline. And then you've got common kind of ops stuff, right? Basically, is this table populating in order to feed the training or not? And that can be things like, ML engineers or even just software engineers that are experts in, for example, Airflow or like other kind of scheduling, job scheduling type things. Of course, data scientists can do all of this as well. It just depends on, which side of the spectrum they are. Are they highly inclined to be statistical and algorithmic rather than software oriented, or what kind of mix do you have? And then I think for the training part, this is where, the cadence of training, the data that's required, the parameters that are required, I think that requires a lot of input from data scientists. At the same time, inference also requires that. Now, the part where you get more help from people that have stronger skills in software are situations when, inference becomes, it's like SLA critical. So that means you want your timing to be, you need to reply with your prediction in, let's say, a millisecond, 5 milliseconds. You have a tight bound on how fast you need to return this. And we see this commonly, right? If you are a Netflix and you're searching on your phone, this needs to return in pretty quickly. Otherwise, users are going to be frustrated. So how do you get your inference to be that fast? And typically, I will say that anybody with strong data science skills would not have invested deeply enough to be able to solve that kind of problem. And that's where you need engineering help, right? How do you make these training pipelines? And then therein lies the challenge. How do you make sure that any new innovation that data scientists coming up with, or a machine learning research person is coming up with, can be amenable to these like high speed, like the ability to make predictions at high speed? So I think in terms of a mix, it's definitely data engineering, software engineering, and data scientists. Those three components are pretty much cover most of this if you align it along the actual needs of what you were trying to build.
Great. That's an awesome perspective. Gives us a bit of landscape. And as we've been talking, there's been a lot of questions coming in. So we'll start addressing some of the audience questions. And for the people listening, please post your questions on the Q&A section, because if they go on the chat, they might get lost with the rest of the communication or the rest of the conversation that we encourage everyone to have. So I did see one which is directed at Kendra. So I'll ask her first, and then if anyone else has any thoughts, jump in. And it's about testing. So the question is from John Hawkins. Hi, mate. And he says, interested to know how you manage the build it, you own it culture. Do you get data science teams to adequately test and support, and the support being after hours as well? How does that component work for you?
Yeah, so I think I did say we don't have data science teams. We treat machine learning products like any other product, and therefore, right from the very beginning, we have a team that is mixed between, we call them applied scientists. I think it's probably partially between what other folk on the panel are calling a data scientist and a machine learning engineer. We have applied scientists, data engineers, to Farhan's point, and application engineers working all together. So it isn't a case of, the question might be around is something that Farhan touched on as well, which is, hey, folk who have invested a lot of time in understanding the mathematics of ML products don't have as strong a background usually in writing production software. But we don't have a data science team. We don't have a team made up of folk whose qualifications and experience you might say would be more algorithmic. We have a delivery pod that is made up of folk that is their specialty, and folk who are dyed in the wool from the beginning, have built application software. So support is managed inside a pod. And just like you might have, first level support, second level support, third level support, I'm sure most of your listeners will be familiar with this. The chances that the problem is with the algorithm are extraordinarily small. The first problem probably is that it is in the data stream. So it is more likely to be the data engineers that are actually doing after-hours support. I would see the ML sort of application scientists, sure, they are there and they are absolutely committed to answering the problem if there really is one, but it's unlikely to be the service is down, fix it now problem. It is much more likely to be bugger, this does not work as well as it did 3 months ago. What unidentified source of drift do we have in our stuff? And that's not something usually that you need to fix at 2 o'clock in the morning. So I hope that helps, that answer.
Helps a lot. And it was related to a question that we have from Sab asking about how important data engineering knowledge is in MLOps. And from that answer, we can see very, very important and definitely critical component. Any other thoughts on the supporting and testing parts from anyone else?
I think one thing I will say is that in my experience, what we've found is that there are two kind of models. One is where you pair data scientists with, say, an engineer, and you help them productionize, and that becomes like almost the engineer is taking on a consulting role, and it doesn't scale. And the better model has typically been that engineers build tools of self-service for data scientists, so that part scales much better, because now that I'm a data scientist, I don't have to wait to get this process prioritized by engineering to get it into production. So typically what we aim for is that there are self-service tools in place to put this thing into production. And then once it's actually in production, you kind of have to mix the kind of policy that you use in terms of maintenance. So what that means is you would literally have a hierarchy or an escalation policy saying, when this happens, can an engineer take care of it? And if they can't, then they move one step back and say, hey, I can't figure this out. Next on call is, let's say, a data engineer. Next on call is a data scientist. And that's kind of like, a policy that I've seen work, where you have engineers provide tools that help data scientists scale. And then in production, you have a sort of policy that says who's the first, line of help, and then it escalates from there, or it goes deeper into, okay. And to Kendra's point, it's rarely that the algorithm, there's something, going on. It can happen, but typically it's the data.
I think just to add or even support what Farhan said, I totally agree that machine learning engineers are there to help the data scientists by building self-service tools and make their jobs easy. Sometimes it can be a very clunky and manual processes for data scientists. So how do we build that, automation pipelines and bring in that efficiency in the overall end-to-end process is one. And secondly, when we talk about issues, there are two kinds of things, right? One being operational issues itself. Like, of course, those are the ones that you would need your MLOps team to look into and make sure that the end result is achieved. That's one. But then the second one being the ongoing performance of the model itself. Like, every model goes through a process and it decays over a period of time, right? How do we ensure that we set it up in such a way that there is retraining happening, and in an automatic manner? And that's where MLOps comes into play as well. So again, doing it at scale and doing it for efficiency is going to be the key to have the MLOps team supporting the data scientists. And it's going to be absolutely critical as you want to expand that in an organization, of scale, like Woolworths, for example, or Woolies X.
So at Castles, we're doing something similar to like what Kendra said. We own it. Yeah, we build, we own it. Yeah. For data scientists to build a model and then to productionize it, they need to be paired up with a software engineering team. Like currently, it is our team. Yeah, but in the future, we want to actually them to pair up with any team that have AI enablement within. So when there is an issue, the first line of call definitely, of course, will be the engineering team who actually run the service. Yeah. Say like if you deploy the model as an inference as a REST API, there's some issue there, engineer will have to look at it. And then if there is if the issue actually find out here within the algorithm of the model, they will get passed to the data scientist. And there's no issue because when they productionize the model, this engineer and the data scientist, they work together. Yeah. So there is a bit of overlap in knowledge. The engineer know a little bit about the model, and the data scientists also know a little bit about how the productionization happened. Yeah. So given with that kind of like a synergy, yeah, the team actually work well together. They feel they really own it from end to end, not just like I'm building a model. It's your job to productionize it. And the engineer also can do the other way. Like it's not my problem, it's just your model problem, right? So we want to build this kind of like good synergy between the two. Yeah. Overlapping is very important. Yeah.
That's great.
This connection between engineers being front on the line. I always have a hilarious out of office reply automated one that says, for all your prediction emergencies, please contact this other person. So it's rarely actually a prediction emergency, but it can happen.
I love that. That is excellent. That's great. So definitely gives us a good insight into the teams, different team structures, different types of skill sets that are required, the importance of engineering, and then the flexibility of having engineering largely centralized. Obviously, it's always a spectrum, but one side having engineering largely centralized, creating tools to empower data scientists, and then on the other side, on the other end, pairing data scientists and engineers to help build and deliver and serve the models at scale and at speed. So I think that's really, really good. One of the other areas that we've been getting a lot of questions in is around retraining models, automating that process, and then the flow of having new models coming into production. And it can be new models that are trained or are predicting something new, or new models that we're hoping that they replace existing models in production. So definitely there's a bit of sort of automated metrics, automated retraining, and then maybe a champion challenger approach in how the new models get selected. And then when they go to get deployed, how are they deployed? Do they start with very low amount of traffic, of data traffic, and then they get expanded over time? I'll throw it open to the floor on your perspectives on model retraining and in that flick over to production.
Well, I can start first. So at car sales, we have a platform for the continuous training. So when the model gets productionized, the software engineer who is responsible to do the task will build something called a training pipeline. Yeah? And this training pipeline is like a bunch of steps to data extraction, preparation, cleaning, and then building, executing the model training. And at the end, there is a validation point to check if the model achieves a certain accuracy, minimum accuracy. Yeah, if it is less than that, we will not deploy. Yeah, so if it is actually past the threshold, it automatically deploy in replacing the current model. At the moment, we do not have any like a canary kind of like a deployment, like taking over the traffic slowly with the taking over the old model traffic slowly with the new one. Yeah, not yet, but we aiming to have that as we grow in maturity and more adoption in our AI tech. Yeah.
Great, that's really good. How about others? How does it work on your side?
Gosh, it depends. It's one thing I find quite interesting. I think software engineering being a much more mature discipline, perhaps, than what we're talking about, is I always struggle a little bit with like, it depends. Like, this is a very, very broad space. And yes, almost you could just say yes to everything you said, Felipe. All of those things happen. Maybe I would pick up one interesting difference that I think comes out is, I think particularly what a lot of is talked about online is there are two relatively different types of machine learning products, I think. And I think they lend themselves to different ways of development. Then I am not passing judgment on either type. I'm saying there are two quite different types, and I see them talked about perhaps where people overlap them. I think there is an instance type where you are running thousands of copies of a very similar model with perhaps regional variants. So if you're an Uber, or if you're a Netflix, or if you're an Apple, I'm sure. And that leads itself really well to you genuinely have a sense of scale, and you can do things like putting a lot of effort into your feature factories, your deployment, your all that sort of stuff. There's another aspect of ML, and I think it possibly tends to be where some smaller companies might start. You don't have that hyper-regionalization, so it doesn't really help you to run 1,000 different copies of the same model, but you have 2 or 3 particularly impactful workflows in your company where it is actually worthwhile building. It's why I always call them ML products, not models. The model is a tiny piece of any useful product, where it is really worth your while building relatively bespoke pipelines for those very, very impactful applications. Where you're doing that, I think the point that Gus was making is really, really useful and impactful when you're doing hyper-regionalization, lots of very, very similar copies perhaps. One thing that we find in Xero is that we're dealing with stuff that is subjective enough to the user that where we put a lot of, sure, automating deployment, great. Should we do it? Yes. Can we do it? Yes. Being able to deploy something 5 times an hour is not really particularly helpful. I know that's not what Gus was saying, but we put less of our time and effort at the moment into worrying enormously about sort of the automation of deployment, because we are still at this phase of wanting to spend significant amounts of time really understanding how the customer experience tracks to the metrics we can see. So I guess what I'm saying is the customer workflows that we are working within are complex enough that a lot of our effort and interpretation goes into, has this change made a gainful impact for our broad spectrum of global customers? So I love the MLOps side of automate the bejeebers out of anything you're going to do more than 3 times. Completely agree with it. Interestingly, is not actually where I see my ML product teams spending the majority of their time. They spend the majority of their time in sort of inside that customer problem of, okay, I did this change. Now, how do I figure out what the genuine user impact of that change was?
I love that. Yeah, and I love the both the clarity in the thinking and help us better define the landscape. Also with the perspective that it does depend on the organization and what they're looking to solve. And then you also opened up another door that the measurement on how valuable the model is, it expands beyond accuracy, and that there's business metrics and experience metrics to be considered into when we're looking at how good a model is, how helpful, and is it better than what we had before. So I'll ask maybe Ram, any thoughts from your perspective on how you guys go through the MLOps process and how you think about models in production and what it looks like getting better models out there. Oh, good.
I have to do at least one time in a day. I think when it comes to the performance of the models, and I'll go there rather than MLOps and technicalities, because I'm sure this panel is covering some of those topics. For me, it's about at the end of the day, what sort of impacts are we creating for our customers, right? And the customer metrics are very, very important. And we spoke about some of the business metrics, and we measure that because it's important to measure the outcome that we were trying to achieve from the modeling that we were doing. Like, for example, it could be acquisition of new customers being one of the targets variables that we decided to do through the machine learning model. So we need to be able to actively monitor that, actively look at whether we are meeting our targets, and if not, then we need to look at what's happening, whether it is a data issue or whether the model can be tweaked, or whether we could add more features. There's a lot of different things that we could be doing here to optimize the models, right? And again, this is something that has to be done as a collaborative effort. It's not just the ML engineers or just the data scientists. And it has to be the business as well, coming together and working together and making the product better, so that we are able to serve our customers better. That's the most important thing. So we continue to track the different metrics, and and there are different business goals or objectives that we want to achieve through the AI modeling that we are doing, and we want to be continuously improving that, and MLOps help in a big way to automate, to monitor, to retrain the models. And again, I'm going back to the word efficiency, because not all data scientists would have a software engineering background, for example, or may have the data engineering background, and they might be really good at building algorithms or using the right machine learning algorithms or the statistical techniques and so on and so forth. So it's about getting that right combination and making sure that we are able to create that impact and a positive impact for our customers that we serve.
That's excellent. Yeah, thank you very much. Farhan, were you going to jump in there?
Yeah, sure. It's a little bit of a long-winded point, but I just want to bring it up because I think it's important. So it's to back up what Kendra was saying. So there's a very interesting blog post by Andre Karpathy, who's the director of AI at Tesla, where he talks about software 2.0, where basically software 1.0 is what we commonly know as code we write that we compile into a binary and that executes, right? Whereas software 2.0 is actually us giving the software or writing the architecture, but not having, for example, the weights in, right? And so software 2.0 is composed of the training data that you give, the framework or the architecture, whether that's a linear model or a tree or a neural network or whatever, the weights that are ultimately learned. And that's actually finally your compiled kind of binary that gives you the output. So what the point I'm making is that that piece of software, it's almost like you're changing code every time you retrain. And what does code change imply? Code change implies volatility almost necessarily, right? You're going to have some change, most likely a break. And so what you really want in a lot of software systems is minimal code change. And when there is a code change, it's heavily scrutinized and made sure that it's actually valid, right? So what happens with retraining and regular retraining is that you're actually changing software. And when you're changing software, you are fundamentally destabilizing the system. So even though we run things at scale and we need them to scale, for example, the example that Kendra gave about regional models where I've been there and we've had regional models up to like 700-800 models, right? But imagine this, right? You have 700 or 800 models and you are training them, let's say, daily. And predictions are all over the place, all sorts of alarms and alerts will fire, and you will just have a really bad time. So actually there's something to be said about stability of a model, and that's where your algorithmic skill comes in. Can you make your algorithm generalize enough that it can take care of some of the drift? Because if it can't take care of any of the drift, you have a pretty unstable model. So you should go back to the drawing board and say, get me a more stable model and let's make this training daily. Let's make this training, every 6 hours, not hourly, because if it's hourly, you've got something going on. So as a matter of fact, when we have scale, we actually do look for stability. Things like when we ship a product on an iPhone, we have over 1 billion active devices. We need stability, right? So there's this balance that you have to have that, yes, on the one hand, you have MLOps, and that helps you retrain regularly, and you do it in a systematic way. But from just a purely training perspective, it's not always beneficial, even from an algorithmic standpoint, to be doing it so regularly.
I love that perspective. The summary, I think, maybe is really helpful for the audiences. What is your pain point at the moment won't always be your pain point. If you then yes, you should put your effort into MLOps. Once you get to a point where you can deploy relatively regularly, you're going to get to the point where something, that's not really very important anymore. This is really important. And you're going to work on that until it's better. Then suddenly you're going to be back in the pain point of we can't deploy quickly enough. And I think as teams mature, they go through that leveling up. And perhaps the most important thing we could help folk on the call understand is it flips. And just because you're in one place now, if you work on the maturity of your team and what you do, you'll flip to another one. If you don't know you'll flip, you might spend too long trying to over-optimize one piece of the whole system.
I love that. I love that, and definitely, I've seen that happen in terms of not having the clarity and overshooting the optimization on one side, and then almost being dragged into improving the other side, and when after a penny drop moment. So that's really great. We had a question from Balkan. Hey Balkan, asking about how to estimate the time and effort required to implement ML models. So big smile from Kendra there, definitely. And what kind of strategies do you guys have to improving the estimation accuracy? Maybe we'll start with you, Kendra.
My answer was going to be iteratively. I do think it is one point where, particularly if you're building a relatively new ML team inside a company, you have to spend a lot of time helping the teams you work with and around understand that it is a little different. And that's not us saying we're precious snowflakes, we do things differently. It is genuinely, I can't actually tell you whether I can build a human useful algorithm or a human useful pipeline until we have spent a significant amount of time kicking the data.
Mm-hmm.
And then after that, I might be in a place where I can sort of move a little closer to the more standard software delivery lifecycle estimations. So it's a roundabout answer, but I think that might be one of my suggestions is try to help people in your organization and in your team, maybe if the team is new, understand that ML products, perhaps you could think about it as going through two relatively distinct phases. One phase is that genuine, we are kicking the tires to see if this is even feasible. And one way we talk about it at Xero is trying to reduce the uncertainty around can we build it well enough to be useful? And is the data good enough for us to build it to that point of usefulness? And we often concentrate on trying to shrink both of those error bars and hoping that they shrink on top of each other.
Mm-hmm.
But keen to learn if they shrink and this is how good it has to be actually useful. This is how good we can build it with the data available today, and they don't shrink to the same place. Cool. Don't try to build that product, put it down. So we try to shrink those error bars, see that they overlap, and then to some extent we do transition, I think, into a different phase of an ML product lifecycle, which is where you can bring in more robust estimation and have a clearer understanding about delivery timelines. It's really tricky if you aren't able to articulate the two different phases to the rest of your organization, because then they just get into this thing of you guys just sit over there and play for a while, don't you? And it's yes, but no. So there you go. That's my answer.
I love it. Gus, from your perspective, big smiles from you there through Kendra's answer.
Whatever Kendra said is spot on. This is a problem we're dealing with at Castle as well. I've always been asked how long it takes you to build this?
Yeah.
How come you cannot give me an estimate how long it takes, right? So and to Kendra's point, we also divide the phase of the development of machine learning technology as two phases. First, actually we call it POC, yeah, and depend if this is the when we look at it. Actually this is something that very similar to what we've done earlier. We can give them a rough estimate. But if it is something new, especially touching a new data source that we never touched before, right? Because majority of the problem is that you do not know how to build a model, right? But the data availability and the data quality is the issue, right? And you never know until you actually pull the data and play around with it. Oh yeah, so many issues with this data. This table does not join with that table. This data is missing for 6 months period, right? So we always enter for this type of project, we give them a POC, like time box, 2 weeks, 3 weeks, or 2 months, depending on the complexity, yeah? And then during the POC, we do iteration, right? We try something small, pull the data first, do exploration, and we report back to the business, to the stakeholder. Hey, based on our initial iteration, this looks like not that hard. Or we do not know yet. We need to put more effort to do a bit more exploration to know more. Yeah. So once we already confirm, okay, this is data availability is okay, then we start jumping into building a very small model product. Just use a simple model, right? No need neural network, complicated algorithm, right? Just to see, just with a simple algorithm, what accuracy are you getting roughly? Yeah. So with that, we can extrapolate. Okay, so if you go to neural network or time series, I don't know, NLP transformer, whatever it is, how much improvement we can actually make extra on top. From there, we can give them estimate. Hey, this will take roughly about this long. Yeah, and accuracy ballpark within this figure. Is this acceptable? If they say okay, yeah, time-wise is okay, accuracy okay, then we go ahead into really building it. Yeah, so this is actually better win-win because the stakeholder no need to invest 6 months. Yeah, and at the end of the 6 months, we tell them okay, it's not possible, right? So wasting their time and money. At the same time, we actually iterative slowly reporting back to them to give them an informative data to make an informative decision. Are we going ahead? If yes, then this is how long it takes, and this is what you're gonna get at the end. Yeah. So yeah, so that's really what I'll take, and that's solves a lot of my headache, really. Yeah. So it's better communication with the stakeholder from there on. Yeah.
I love it. I love it. Thank you so much. I know that we're coming up on time for this panel, and we have lots of questions from the audience and lots of comments that
we didn't get a chance to address in this panel. Some of the answers are coming throughout the day, but also we will continue the conversation on the Data Futurology Slack community. I'll post a link now for everyone who doesn't have it. Please join the Slack community. We'll put the questions that came in through this session and all the sessions today. We'll put them on the Slack community, and then we can all continue the conversation and continue to engage on these topics now and ongoing. So thank you very much to our panelists. Thank you, Kendra, Ram, Gus, Farhan. This has been amazing, fantastic kickoff to the day, providing so much depth and a better understanding of the landscape. Now we will move on to the next session, which is around MLOps processes and understanding differences between them. Thanks everyone for joining, and please continue to stay with us throughout the day. Thanks again to our panelists.
Thank you.
Thank you.
Bye-bye.